We'll discuss here vertical stretch and compression. Here is the situation. Suppose that the graph of the function g of x is given, and we want the graph of the function c times g of x, where c is greater than 0. How the multiplying by c, how multiplying g of x by c would change the graph. If I were to make the table of values for that function, then I could use the same x coordinate for both function g of x and c times g of x, because those two functions have the same domain. Now, if the b is the y coordinate of the point on the graph of g of x, then the y coordinate of the point on the graph c times g of x will be c times b. The y coordinate is multiplied by c while x coordinate stay unchanged. If c is greater than 1, then the value of y, c times b, is increased 3 times, and this transformation is called the vertical stretch. If c is between 0 and 1, then multiplying b by c will reduce value of y c times, or 1 over c times, and therefore this will result in a vertical compression. Let's look at an example. Let's use transformations to graph function f of x equal 3 square root of x. We can think about the function f of x as the function 3 times g of x, where g of x is the square root of x. We know the graph of the square root of x. This is one of our basic functions and is graphed in the coordinate system. So we'll be transforming the graph of g of x to obtain graph of f of x. So let's see how the points will change when we move from the square root of x to the 3 times the square root of x. So let's say I have here y equals square root of x, and the points on the graph are 0, 0, 1, 1, and 4, 2. Now if I consider now function 3 times square root of x, then what happens here? The x coordinate stays unchanged. The y coordinate is multiplied by the 3. So we'll have 3 times 0, and therefore it is 0, 0. Origin does not change because multiplying 0, y coordinate, will still result in 0. Therefore, for vertical stretch and compression, the x-intercepts stay intact. The point 1, 1 will become point 1 and 3 times 1, which is the point 1, 3. Point 4, 2 becomes the point 4 and 3 times the y, which is 3 times 2, and this results in the point 4, 6. So the points on the graph of the function that is stretched are going to be 0, 0, 1 and 3, and 4 and 6. And if we join those points with the continuous curve, you will see the graph of the function y equals 3 square root of x. As you can see, it has been stretched away from the x-axis. Every y coordinate of the point on the graph of y equals square root of x has been multiplied by 3.